Hey guys, we're going to go over Q3 on the final exam review worksheet. This is an extra question, but I think it's a really good overview about LLRB trees. With that being said, let's get right into it. So for each of the situations below in a valid LLRB tree, indicate whether the node is red, black, or either red or black. An example of what we mean by value and color, it gives us a little diagram, and it's saying in the above LLRB, the node with a value A has a color of red, while the node with value H has a color of black. So these questions aren't necessarily based off this diagram. They're more of like conceptual overview questions. If we understand the rules of LLRB trees, this is just helping us visualize like the red and black nodes. So let's jump right into QA. Question QA, yeah. The largest value in a tree with more than one node. So we know that in LLRB trees, the largest value is going to be on the right side. And we also know that red nodes can only be left-leaning. So because we're looking towards the right side and we're not going to find any red nodes on the right side, the answer for this is going to be black because the largest value is always on the right child, so it must be black. Moving on to QB, the smallest value in a tree with more than one node. A key aspect to this question is it's saying with more than one node. If it's more than one node, then we have two options. We have a 2-node 2-3 tree, and we have a 3-node 2-3 tree. And in both of these cases, the smallest children are going to be different colors. And because we're asking for the smallest value in the tree with more than one node, this answer is going to be either. Because a 2-node 2-3 tree has a red smallest value, and a 3-node 2-3 tree has a black smallest value. So because it's telling us, it's asking us about a tree with more than one node as opposed to just one or just the other, we have options, so it's going to be either. Next, a node whose parent is red. Now, this is testing one of our key fundamentals of LLRB trees. One of the rules is we cannot have two consecutive red nodes. So we can't have a red parent and the child is also red. That is breaking a rule. And because this is asking about valid LLRB trees, the answer for this is going to be a black node because there cannot be two consecutive red nodes. Next question, a node whose children are the same color. This is once again testing one of our key fundamentals. We know if we have two children and both the children are red, we do a color flip. So because we do a color flip, we can assume that the children that are the same color is going to be black in this case. Because we have black children, the answer to this can be either. A node with two children of the same color must be black, so it could be either red or black because there's no rule telling us we can't have two consecutive black nodes, and there's no rule that says we can have a red node with black children. The last question, a freshly inserted node after the insertion operation is completed. Keyword about this is it's saying is completed. This is because there are so many operations that can happen for BST to be complete. So you could go through rotations and color flips and rearrangements. And after that, even though you may start with one color, the color may flip. So the answer is going to be either for this case as well. And yeah, that was it for Q3. If you guys have any questions, make sure to ask on Ed, and good luck studying, guys.